So we're getting to that time of year now where as forecasters, we're not only forecasting whether or not it's going to rain, but we're having to decide whether that precipitation is going to fall as rain, sleet or snow. So I'm sure you're aware that the main driving factor of this is of course the temperature of the air. And generally what we see is that the temperature from the surface decreases with height. So generally we get the warmer air down at the surface, and then up aloft at the cloud height it's obviously much cooler. And generally as well you get temperature decreasing with height above sea level as well, so that's why the temperatures on top of the hills are much cooler than the temperatures down in the valley. So you can see in this example, all three of these, rain, sleet and snow, the precipitation coming out of the cloud is as snow because it's obviously so much colder up at height. So even if it's raining down at the surface, for much of the time that will be falling as snow up aloft. And then generally as that snow falls through air that's warming up as it gets close to the surface, it just begins to melt, and then by the time it's at the surface it's falling as rain. So that's the standard situation with rain. It just melts as it goes through warmer air coming to the surface. Now with sleet and snow, it's basically the same principle, but that air is just a little bit cooler. So either at height or even if there's that cooler air down at the lower levels as well. In sleet, the snow doesn't quite have a chance to fully melt into rain. You can see there's a mixture of rain and snow as it partially melts and then falls to the ground as a wintry mix. So that's basically when the temperature's not quite down to freezing, but just cold enough that some of those snowdrops manage to make their way through to the surface. And with snow, basically the whole atmospheric column is below zero, so it just basically doesn't have time to melt and then falls to the ground as snow. So that's the general gist of the differences between rain, sleet and snow. Like I mentioned, at altitude above sea level, you get that falling of snow. So here's a nice example here. You can see up on the hills here and then across the valley there as well, the precipitation has fallen as snow. We've got a nice covering of snow here. But down at the lower levels where it's just that bit warmer, that's changed to sleet and then further down into rain. And so there's no accumulations at the lower levels because of the slightly warmer temperatures down in the valley. So looking at that in a little bit more detail, this is the lowest levels of the atmosphere up until about 3 kilometers. This is temperature versus height upwards, and these three lines denote the air temperature for both rain, sleet and snow. So starting with the rain example, you can see in the lower levels the temperature is still decreasing with height, but the entire way up at the lower level of the atmosphere, that's staying above zero, so it's falling as rain. It's melted from the snow further aloft. In the situation with snow, you can see the entire atmospheric column is remaining below zero. It's still the warmest at the surface, but that temperature is below zero, so that's falling as snow. And then with sleet, the temperatures are close to zero, but just warm enough that a few of those snowflakes are starting to melt. And then you get this wintry mix, which is the temperature column somewhere in between sleet and snow examples. But it's not always as simple as that. It's not always the case that temperature straight up decreases with height. In this situation here, you can see we've got this cold layer at the surface and then some warmer air aloft before then it turns cooler further aloft. So this situation happens when you've got a cold air mass over a certain area, and then you get a warm front pushing through, which can bring warmer air aloft and bring some rain as well. So this warm air generally pushes over that cold layer. And it's the same principle in this area that the snow melts to sleet, melts to rain, but then as those raindrops fall through that cold sub-zero layer, they can refreeze as what's known as ice pellets and then fall to the surface as that. So that's why you can often get that where it's been raining above, but then the cold layer at the surface allows that rain to refreeze. And if this cold layer is even shallower, you can see in this example, the rain doesn't quite have time to refreeze. So it basically, with that cold sub-zero layer, it instantly freezes on the surface, and that's what's known as freezing rain, where it falls through as what's known as supercooled water droplets. Basically doesn't have time to freeze and then instantly freezes on impact with the sub-zero surface. So that's the difference between freezing rain and ice pellets. It's all to do with the depth of that surface cold layer. Again, taking just a little bit more detailed look at that air temperature, it's you get this cold layer at the bottom, the rain's falling out of this warm layer. As it passes through the cold layer, it freezes or instantly freezes on the surface depending how high that cold layer is, and that's basically the fundamental difference between freezing rain and rain, sleet or snow, is that surface cold layer. So I hope that's cleared up any questions that you may have about the differences between rain, sleet and snow and what causes them. Thanks for watching.